Hello friends, this is Nanesh Rauchar. In last session I started the training on simulation of heat exchanger. Today I will start with the details of the OTS cycle, and in the next session I will explain how to do the simulation for the pump. So basically what is the simulation? Simulation is the mimicking of the refinery or existing plant on a software which helps in the form of model, which helps us to test the different scenario which we cannot test in the existing plant. So basically what is OTS? OTS means operator training simulator, in which we are preparing a model of existing refinery in particular different softwares, uh, which is exactly the replica of the existing plant. And before giving the hands-on experience on the existing refinery, we are giving the training for the operators on a existing model which we prepare in the OTS projects. So what are the different types of steps in the OTS cycle? So particularly there are three steps. First is MAT, second is FAT, and third is SAT. So what is MAT? MAT is the model acceptance test, in which what we are doing, we are first of all taking all the data sheets of all the equipments from the customer. We are preparing the model of existing refinery in the different types of softwares, and we are matching the HNMB of that model, and we are testing the dynamic testing of particular model, so that it is exactly replicating or behaving the same way as that of the existing plant. So if that condition is achieved, then we are connecting that existing model with the instructed graphics, and in the MAT we are taking the startup of that particularly prepared model with the help of instruction graphics, which is exactly replica of the existing refinery plant. Then second step is FAT. What is the long form of FAT? FAT is the factory acceptance test. What we are doing in the FAT, first of all we are taking the DCS data from the customer. We are translating that data in a particular language which is understandable by a model, and we are connecting that DCS data with the existing model which we had prepared in particular softwares, and then again with the help of DCS graphics we will do the startup of particular model. So that is FAT. Then third one is SAT. What is SAT? In the SAT particularly, it is just checking of overall model and all the physical deliveries which were prepared or which were decided at the start of the meeting. It's a checkup for that one. So it depends on the customer requirement, that if it is if they needed any another startup for the particular plant, they can do that startup in SAT also. So these are the three steps of OTS cycle, that is MAT, FAT, and SAT. So first type is, what is pump? Pump is a device which is required for discharging the compressible liquid from low pressure to high pressure. So particularly there are two types of pumps. One is reciprocating one and another one is a centrifugal one. So when the discharge pressure is at higher value, then generally the centrifugal pump is used. When the discharge pressure is a little bit lower side, generally the reciprocating pump is used. So what are the different type of document is required for doing the simulation is, first of all, when we are dealing with the reciprocating pump, we require the data sheet of particularly reciprocating pump. And when we are required for the, when we are dealing with the centrifugal pump, so the flow versus head and flow versus efficiency curves are required. And the third one is the ScanIT software is required for extraction of curve when we are dealing with the centrifugal pump. So I will explain what the details how to extract the curve for the centrifugal pumps with the help of ScanIT. Open the curve with the help of ScanIT software. Go to the file, then open the image, then open the particular curve which need to be extracted. Here you can see on the x-axis there is a flow, and on a y-axis head is present. In the same way, flow versus power curve is there, and flow versus NPSH curve is also there. Here you can see on the right hand side the efficiency curve is also present. So while extraction of flow versus efficiency curve, we need to consider these 0 to 100% efficiency point on the y-axis over here. So I will explain that thing while extracting flow versus efficiency curve. So first of all, we have to select the origin of the curve. So here you can see the set of axis. So first step is click on this 0 point. Here you can see the coordinates of x and y axis, which is 0, 0. Click on OK. Then on the y axis, here you can see on the y axis the flow is ranging from 0 to 15,000. So here I will select the point, and here the x coordinate will be 15,000 and y coordinate should be 0. I will click OK. Then on y axis you can see the range is from 0 to 300. So when I will click on this point, here the x coordinate should be 0 and y coordinate should be 300. So when we click on OK button, you can see over here the angle between the axis. When the angle between the axis is nearer to 90 degrees Celsius, it means that whatever the origin and the coordinates we selected on the x-axis and the y-axis are correct. If the angle between the axes are different, it means that we did some mistake while selecting the coordinates for the x and y axis. So here we need to accept the coordinates. Then here the you can see the two to three types of curves are present. So the first curve is this one, is the operating curve, which is always preferable. Here you can see the operating point over here, which are usually denoted by this triangular form, and usually the pump is operated between this operating curve and this minimum operating curve points. So for the extraction, while the extraction we usually always operated using the operated curve. So here select the first point. You can see over here the coordinates are x-axis coordinate is 2.88 and y coordinate is 273. The same way you need to select at least 10 to 15 points. So I am tracing out all the points, particularly on operating curve only. You can see I took the operating curve point. Then I selected all the points and copy the set of data and pasted that data in Excel. In the same way, we have to extract the points for the efficiency. So for the efficiency curve, what we need to do, again we have to go to the file, open the image and select the particular curve which need to be extracted for the efficiency. We have to follow the same procedure which we followed previously. First of all, we have to find out the origin, then on x-axis we have to select the range. In the same way, we have to select the range on y-axis. Coordinates are 0, 100. I said that, see, the angle between the axis is around 90, so it is acceptable. I said that though the efficiency is given on a right hand side, but it's only for the representation. When we are dealing with the 3 axis curve, so while extraction, we need to consider these points on this x-axis. So here this is the efficiency curve. Usually the curve started from 0 and its shape is like a dome shape. So select the points accordingly, and these points must be on efficiency curve. Select the data and paste on curve. So while selecting the points, the care must be taken that whatever the points we have taken while considering the flow versus head curve, same point should be considered while extraction for head versus efficiency curve. So here I haven't taken one point, so here I am deleting one point over here so as to match the number of points for both the curves. So here we have to delete the flow curve. Here the final curve is like flow versus head versus efficiency, and this curve these points we can input while doing the simulation for the pump.